Hello everyone. In this session, let me explain the different types of a single-phase induction motor. We know that a single-phase induction motor is a non-self-starting motor, and hence we rely on different starting methods. And based on the starting method that we adopt, they are categorized into different methods as it is listed here. Over to the first type of the single-phase induction motor, which is the split phase induction motor. The split phase induction motor has two windings. One acts as the main winding and the other acts as an auxiliary winding. Both the windings are displaced by an angle 90 degree by varying the resistance and reactance of every winding. The main winding is said to have a low resistance and high inductive reactance, whereas the auxiliary winding or the starting winding has high resistance and a low inductive reactance. During operation, during starting, the centrifugal switch is closed and hence current flows through both the main and the auxiliary winding. The main winding produces a flux and the auxiliary winding produces another flux which is displaced by an angle 90 degree. Because of two fluxes available at the air gap, the rotor starts to rotate. At some point when the speed of the rotor is greater than a preset value, the centrifugal switch is open, and from that instant onwards, only the main winding is connected and the rotor continues to rotate. So this characteristics explains the operation of a split phase induction motor. So at the beginning, we have both the main and the auxiliary winding connected to the circuit. And at a point when our centrifugal switch opens, the characteristics switches and this characteristics will be followed. So this is the characteristics of a single phase induction motor which has the main winding alone. And now let us go to the highlights of a split phase induction motor. The starting torque is 1.5 to 2 times that of the full load torque in case of a split phase induction motor, and the starting current of this motor is high and it's about 7 to 9 times of the full load value of current. And here we have two windings, and these two windings are not equal, and because of that we have a non-uniform rotating field. And this split phase induction motor is used in washing machines, air conditioning fans, mixer grinders, floor polishers, blowers, centrifugal pumps, drilling, and in lathe machines. The next type of single phase induction motor, that is a capacitor start induction motor. So as the name states, the capacitor is connected to the auxiliary winding or the starting coil, and we have a centrifugal switch which is closed at the beginning or at the time of starting the motor, and after the motor picks up a certain speed, the centrifugal switch is open and the auxiliary winding is disconnected from the circuit. And because of the capacitor in our circuit, the starting torque is increased even more when compared to the split phase induction motor. The starting torque is 3 to 4.5 times that of the full load torque. And here for this type of motor, the starting capacitor should have a very large value of capacitance, and the starting winding resistance is also maintained low. In order to have a very high starting capacitor value, we use electrolytic capacitors, and the characteristics is as shown here. So we have a greater torque when compared to that of a split phase induction motor, and when the centrifugal switch opens, we shift back to the characteristics where we have the main winding alone. And these are certain applications of a capacitor start motor. And this is A permanent split capacitor or a single value capacitor motor, induction motor. It is also known as capacitor run induction motor, where we don't have, we have the capacitor along the main field winding. So this is the only difference between the capacitor start and capacitor run. So we have a capacitor along the auxiliary winding in case of capacitor start, and in case of capacitor run motor, we have the capacitor along the main winding. And here we don't want any centrifugal switch. So you could see here no centrifugal switch is used here, and its efficiency is high, and as the capacitor is connected permanently to the circuit, torque factor is also high, and we also have higher pull-out torque. And the most common type of capacitor that is used here is the paper type capacitor, and the electrolytic capacitors cannot be used here because we are going to run this motor continuously along with the capacitor, and hence we don't go for electrolytic capacitor. But the cost of the paper capacitor is higher, and the size is also going to be large when compared to that of electrolytic capacitors of the same rating, and that's again one disadvantage. And the characteristics, if we compare the characteristics of a capacitor run and capacitor start, this capacitor run motor is having a lower starting torque, and this starting torque is even less than that of the full load torque. And the application is what we see in our day-to-day life. The fans at our residential houses use this type of induction motor, blowers in heaters and air conditioners, and then the refrigerator compressors and the office machinery, they all use this permanent split type or capacitor run induction motor. And this is the next type of induction motor, which is capacitor start and capacitor run induction motor. So here we are going to use two capacitors, and hence it is also known as two value capacitor motor. So this is the schematic diagram of a capacitor start, capacitor run induction motor. So we have the main winding, and the auxiliary winding is connected through two capacitors. So we have a starting capacitor followed by a centrifugal switch, and we also have one more capacitor which acts as a running capacitor. And when the motor starts, the centrifugal switch is closed, both the capacitors are connected in our circuit, and after the rotor has gained the speed, the centrifugal switch is open and the starting capacitor is taken out of the circuit. And we have the running capacitor connected to the auxiliary winding always. And because of this, we are ensured with a quiet and a smooth running, and the efficiency is also higher when compared to that of other motors with which run with the main windings alone. And it is possible for us to have a higher pulling torque or pull out torque, and hence you could move high inertia loads as well. And this capacitor, two capacitor motors are used in pumping equipment, refrigerator, air compressors, etc. And this shows the characteristics. So we have the main auxiliary winding along with both the capacitors connected, and as soon as the centrifugal switch opens, we have the main auxiliary and the run capacitor connected. So this ensures that there is a smooth operation. Okay. And the final type of induction motor is the shaded pole induction motor. This shaded pole induction motor is quite different from the other type of induction motors, because here by construction itself we make some change. So we have a shaded ring or a copper ring at one portion of the pole alone. Okay, so we have the main winding wound over the pole piece, and a part of the pole piece has a shaded ring, and hence it is known as a shaded pole induction motor. So the shaded pole induction motor is going to rotate only in one particular direction, and we cannot reverse the direction of rotation. And to the main these terminals, we supply single phase alternating current, and we don't require any commutator or brushes or collector rings or any other part for taking in the current. And we also don't require a centrifugal switch, and hence the chances of failure are less. So the speed of rotation of this motor is going to be inversely proportional to the number of poles that we use in the motor. So over to the construction, we have salient poles, and the poles are projected towards the armature of the motor. So we could have a two-pole structure or a four-pole structure, and in order to avoid the hysteresis loss or minimize the hysteresis loss, we use laminated poles. And we know we have two portions. One is the shaded part and the other is the unshaded part. So this comprises of the stator, and we have a rotor which is going to be similar to that of the rotor of a squirrel cage induction motor, and the bars are skewed at an angle 60 degrees so that we could get a better starting torque. And when we talk about a shaded pole induction motor, they are always rated with low power rating because the power factor of this motor is very, very low. And the starting torque that we get out of this motor is also very low, and hence the design is kept small, and the motor has low power ratings. And this slide explains the working of a shaded pole induction motor. So because of the variation in flux that is being generated here, so along the unshaded portion, because of the current that flows here through this main winding, a field is created, but more dense field is created here. So here we have a scattered field, and here at the shaded ring region, we have a dense field. So here we could see that it is, we experience a difference in flux, and hence the rotor starts to rotate. And this shaded pole induction motor is suitable only for small devices like relays, fans, and which are easy to start. And we use it in exhaust fans, hair dryers, and also in table fans, and in air conditioners, and few other applications are also listed here. Thank you.